Hi, my name is Tiagi, and in this video, I'll be going over how bioprinting, a fascinating biotechnology system, works. So to start, I want to go over some quick statistics about transplants in the US. So in 2021, 40,000 transplants were undergone in surgery. And so just so you guys know, a transplant is basically an operation where surgeons take a external organ, a healthy one, and they replace it a customer's or patient's organ to make it work. And so the thing is, while 40,000 seems like a lot, the actual supply of organs, right, healthy organs, because you need organs, healthy organs to do a transplant, is way less than the demand for these surgeries. And because of this, there are these huge transplant lists where people have to basically put their name on a government list and just wait their turn until someone has an organ that they can use. And so, just for a quick statistic, there's over 100,000 people currently who are on this transplant list and need transplants and need like an organ to help them. And so these organs are critical organs too. These are like heart organs or liver or kidney organs, right? And so these are really critical organs that, 100,000 people don't have access to because there's just not enough, donated organs out there. And so a solution that many scientists are researching and developing technology is bioprinting. And so bioprinting is very similar to how plastic 3D printing works, but let's just go over how it started. So researchers, they took an inkjet printer, so just a regular paper printer, and what they did is with the printer, an inkjet printer, you have these cartridges, right? And it's filled with ink, different colors of ink. And so what researchers did is they took these cartridges and they filled them up with cells, live cells. Then they printed it. So how the inkjet printer works is it sends blobs of ink on a platform. And so they sent these blobs and they made, basic little structure, maybe like something like that. And then these cells, they did what they naturally do. They were able to bond and mute and, create new cells. And eventually this created, living tissue. And so this first type of bioprinting worked based on just sending these blobs of live cells, and eventually these cells would, do what cells normally do, combine and, create new cells and become tissue. And so the idea with bioprinting today, there's many types of bioprinting, but the main type is extrusion-based bioprinting. So extrusion-based bioprinting, the idea is it's very similar to how a 3D printer works. What you do is you have this, ink cell, right? And you have an extrusion here. And so this ink cell is filled with this thing called bioink. And so bioink is this material that we can use to create cells. And so bioink, what it's made out of, if we look at it closer, it's made out of these things called hydrogels. And these hydrogels allow for the structure to, be supported and stand up on its own. So it has hydrogels and also has, obviously live living cells. And the interesting about these living cells, the interesting part, is that these cells can be taken from the actual patient who needs the transplant or the organ. So you can take these cells from the patient, and you can do this by just taking a little biopsy. And a biopsy is basically a process where you just cut off a little piece of the patient's body to use. And so by taking a biopsy, and the biopsies are like, 1/2 the size of a postage stamp, you can grow these cells and use them for your bioink. And by doing so, you can really solve a huge problem in the transplant business, which is the problem of rejection. Right? So with traditional transplants, you have to get transplant organs from other donators, and the issue is our bodies, these are foreign invaders, right? They're not our cells, they're from someone else. And so sometimes what our immune system does is our immune system attacks these organs because it doesn't know that, oh, this is supposed to be helping me. It thinks that it's just a foreign invader, a virus or something. And so attacks these, um, critical transplants. And so the solution is what they do with transplants typically is they give the patients these suppressors that suppress their immune system. So basically, they take these drugs that suppress their immune system. Now, obviously, that isn't a great idea, right? Because then you're more susceptible to viruses and sickness. So better idea is instead of using someone else's organ, if you're able to use your own cells to generate a new organ, which you can by bioprinting, or theoretically you can, then that would solve the rejection problem. And so yeah, that's the idea. You take cells from the patient, and you're able to solve this huge rejection problem in the transplant surgery. So, anyways, back to bioprinting. So you also have that, and you also have living cells, and you also have inside this bioink, you have these chemicals that encourage communication plus growth. And so these chemicals make the process faster. So when the ink comes out of the platform and lands on the dish, it's able to grow the cells faster and create tissue faster with these chemicals. So finally, how does it actually get out? So you have on the printer, it's very similar to a printer, right? You have a nozzle, and this nozzle is usually around 400 microns in diameter, no more than that. And so that's really tiny. A micron is 1/millionth of a meter, so it's super duper tiny. And so these microns send a continuous stream of bioink to a dish. Okay, and this bioink can then accumulate in layers. So like 3D printing, if you've ever seen a 3D printer that has layers, and so you can have one layer here, one layer here, and you keep adding layers, you can create tissue and organs. And so once you have your bioink all laid out, and oh yeah, one more thing. Also, it's very similar to how a 3D printer works. This moves in the X, Y, and Z direction. So it can go up, down, left, right, and this allows it to move the nozzle and be able to print the right material in the right place. And so once this material is printed on the dish, what you have to do is make sure that it stiffens. So some bio inks automatically stiffen, so you don't have to do anything to them. But others, you have to add a UV light sometimes to make it stiffen, or you have to use chemicals or physical processes like cooling it to make it stiffen. And then the idea is once you stiffen it, there you go. You have your tissue, you have your organ, whatever, and you can now use that in a transplant surgery, and you can use it, without fear of rejection. Oh yeah, but you also need to wait for it to multiply. So after this process, you have to wait for the cells to multiply and to actually create the tissue. Because what you're doing is you're setting up like basically the base of the whatever you're creating, and then the cells actually have to multiply and do most of the work once you've created the structure for it to, multiply in. Another thing that bioprinting does is sometimes they have this gel here, because the issue is with this printing system, you can only really print 2D stuff or very basic 3D structures. And so to make it more complex structures, you sometimes have this gel here, this biogel, and you have your nozzle that extends inside the gel. So what this gel does is it suspends the bioink in place. So you can now print three-dimensionally, and your ink, your bioink, is going to be structurally supported by the gel. So you can now make 3D structures with support. And again, this is very similar with 3D printers. If you've ever seen a 3D printer, you can see that a lot of 3D printers, when they're building complex structures, they make structure supports in the actual design so they can support the object when it's being built. Same thing here, we just use a gel to make sure that the bioink can be supported in that structure, in that pattern. Okay, so what has bioink actually been able to do? Bioink has been able to do bladders, it's been able to do facial tissues, living tissues even, skin, and cartilage. Currently, it hasn't really been tested that much on humans. It's basically been tested on rats and mice. But the research has still been going, and there have been some successful human transplants using bioprinted material. Now, the challenges with bioprinting mainly involve providing providing oxygen to all the cells during the process, right? Because the issue is if you have your bioprinted material and you're printing it and you stack them on top of each other, they could lose oxygen. And you need oxygen for the cells to survive. And so the issue is that some people it's hard to provide oxygen to these cells when you're bioprinting. And so because you're not able to provide oxygen, it's harder to create complex organs. Additionally, complex organs also require different types of cells, which makes it even more challenging to use this process. Because again, you could add more fluids. You can imagine that we could have different fluids in here with different cells of bioinks. But again, if you have these complex organs will require a lot of different types of cells, it becomes way harder to create it. And also the structure material, this isn't really. It's kind of hard to make the structure as well because it requires a lot of precision that is kind of hard to achieve, even with this, expensive, delicate machinery. But we have been able to successfully create mini versions and semi-functional versions of things like hearts and kidneys and livers, right? So researchers at universities have been able to create many versions of these critical organs. And extrusion-based printing isn't the only method being researched right now. It is the main one that people are focusing on, but there are other methods. There's inkjet, that's the earlier method I was talking about. Inkjet isn't really used that much anymore because it's a little less accurate because it uses blobs of ink rather than a continuous stream. And there's also laser-assisted printing, which uses laser pulses to guide droplets and to guide the bioink into certain positions. This is more accurate, but it is still being researched and still a work in progress. Actually, all this technology is still a work in progress. We're still developing and researching it. But the hope is that in a few years, sometimes we might be able to get these materials out to real people and save a lot of lives. But beyond this, we can also think about the future of bioprinting. What can we do with technology? If we're able to create, custom cells, organs, tissues, and we're able to create it on a mass scale, imagine what we could do. We could create new technology that increases lives, right? Because whenever we grow older, we can just replace our organs. We can replace the organs, or we can replace tissue. Oftentimes people pass away, unfortunately, due to organ failure or to tissue failure. And so imagine if we could just print it out, we could help increase life capacity or lifespan. And also, we can even embed electronics into tissue or embed other stuff that makes it, more better. But that's really sci-fi kind of right now. Right now, we're still focusing on getting the main technology working. And yeah, that's how bioprinting works, and that's kind of where the future is. Thank you guys all for watching, and I hope you guys all found this video interesting. Thank you, and goodbye.